parallelograms. And we've said, quick review, since some of you are going to do a retake. Give me a theorem we learned. David. Okay. No, on parallelogram. One of the 6 I said you got to know these 6 for the quiz on Monday. So yesterday's quiz. Give me one. Parallelogram, then what's true? Has to be true. What about? What's it? That wasn't a theorem, but can you tell me what the total has to be? No, it wouldn't be 180. Be 180 because how many sides? 180 is a triangle, right? So what would that have to be? No. How many triangles can we create if we draw lines through that? 2. So how many total degrees? 2 triangles. 360. So now Miles, then and that wasn't a theorem for parallelograms, but it was what we did on polygons. Some of you need to retake that one because that was a pretty easy one too. What is a theorem just about parallelograms? Oh, that's for a triangle. We're not dealing with triangles. Parallelograms. So you guys are kind of telling me that when I grade these quizzes from yesterday, we're in trouble.
I don't even know anything.
So opposite sides are congruent. That was one of the theorems. If the opposite sides are congruent, well, actually, if it's a parallelogram, then the opposite sides have to be congruent, right? So we're learning new theorems. So now look at that page 21. What's the first theorem say? It just is saying it in the reverse direction. So if I don't know, like if they don't tell me that's a parallelogram, but they do tell me that, they tell me the opposite sides are congruent, then that means it has to be a parallelogram. It's the only way that can be true is if the top line is parallel to the bottom line and the left side is parallel to the right side. So we're not really learning anything new. We just have to understand that theorem goes both ways. If it's a parallelogram, then that's true. If that's true, then it's a parallelogram. Again, nothing new. No, I'll tell you the new.
Oh,
This is a new lesson, but it's really a lot of old stuff. Give me another theorem that you were supposed to know for yesterday. You had your hand up. Yeah. Oh, yeah. Are you answering one? Oh, yeah. So one theorem was that if I have angles on the same side, they add up to 180. Okay, so that was one theorem. Evan, give me another theorem. This is not for the new stuff, for what we need to know yesterday. So from memory. What's the other easy one? Opposite sides are congruent and well, that's the definition because the sides are parallel. That's why we call it a parallelogram. But opposite sides are congruent and yeah, don't forget that one. That's the easy one. Opposite angles are both congruent. Sora, what's the next theorem in this lesson on page 21? Oh, is that what the next one is? I'm in the wrong order. So what does it say? Say it again. So what was one of the other theorems we learned for yesterday about diagonals? We learned. What were you supposed to learn? Or what we learned about diagonals? If I tell you that's a parallelogram and I draw diagonals in, what's true? What just happened? Yeah, they bisected each other, right? You were supposed to have learned that for yesterday. The diagonals of a parallelogram bisect each other. So if I tell you that's a parallelogram, then you know those bisected each other. Or it goes the other way around. maybe I don't tell you it's a parallelogram, but I tell you that the diagonals are bisecting each other by drawing those markings in. If this is true, then that has to be a parallelogram. That's what that second theorem is saying. So again, it's not a new concept, same thing we learned before. It's just the way the problem changes is they're not telling you the shape is a parallelogram. They're giving you congruence marks, and you are then making the conclusion that it's a parallelogram. What's the third theorem? I actually thought it was a different second. Chelsea, what's the third theorem? Oh, okay. What's the second? I was going to say, I thought the second one here. That's the one I thought was second. So again, if we said before, if it's a parallelogram, opposite angles are congruent. Now we're just saying the opposite. If we know opposite angles are congruent, then we know it's a parallelogram. So again, all we're doing is just kind of reversing the direction we're going. Instead of knowing it's a parallelogram, we're being given information about the sides or the angles or the diagonals, and then we're determining, oh yeah, well that means it has to be a parallelogram. Now I'll go back to, oh, actually not that. So we did diagonals, we did opposite angles. I think this is the only truly new one right here. This was not one that we really learned. So kind of put a circle around that. And I'll show you what that one, I guess I'll go back to a picture over here. So the new one that we haven't learned, I didn't want to do that. So the new one that we haven't learned, that you will need to remember, if I tell you I have this figure, and I don't tell you anything at all about the left and the right side. So I don't know if they're the same length. I don't know if they're parallel. I don't know anything. All I know is that's true. So top and bottom are the same length. And I do know that the top and the bottom are parallel. That's enough also to tell me it's parallel. Just that, without knowing anything at all about the left and the right, about any angles. The only way this is possible is if those two lines on the left and right are the same length and parallel. Because if I slid, and it's kind of hard to imagine, I could maybe try to create something in the future, but if I took this line and if I slid the bottom line around, I don't twist it or anything, so it's always parallel. The only way to still connect the left side to the bottom left and the top right to the bottom right is if those lines stay parallel. Like there's no other way to do it. If I lengthen this line out, then now this is no longer parallel. So again, if you're not visual, it's a little hard to figure that out. Then you just got to memorize that theorem, 7.1. But again, if I know that is true, and it could have been the other two sides, it doesn't have to be those two sides. I don't think it's got to be top and bottom. It could be those two, same thing. If I know those two sides are the same length and parallel, that's all I need to know. I don't need to know anything about the top and bottom. That is a parallelogram, just based on that alone. Now I'm going to let you go ahead and do the first few problems. So turn to page. Did I not write it down? We didn't. Huh. Turn to page 2. I think it's 26, maybe. No, 25. I guess I forgot to write it last week. Yeah, 25. So here are the problems you're responsible for. I'll give you all of them from this page, but right now you're just doing 1 through 6. So 1 through 6 and then 9 and 10. And you can go ahead and try to do 1 through 6 right now. So you're saying whether or not it's a parallelogram based on the new, I mean, there's, like I said, 3 of them aren't really new. What are the pages? We've been using them since the beginning of this lesson. Same ones we tore out. We only tore out one time. Yes. We've been using them for 2 weeks. You've been here. There's no way you haven't. Look real quick, and if not, I'll give you a book because some of the teachers aren't using the book anymore. But if you got any pages at all, in this I know you tore them out. I'll never use them. You just look for any. It's the only thing. Just look for anything, unless you got like really old, like. Huh? I find it hard to believe. I mean, I know you didn't do anything with them at home. I don't know where else they would have gone. So it'd be page 25, 1 through 6, and then you're also, if you want, you're gonna do 9 and 10 on that page as well. I think I said that. So opposite for.
Yeah, that's one time.
All of the totally different life lessons. And arguably, it might be true. Doesn't last. Some maybe floating around somewhere else, not in here. That's where I think they are. I think they're not in the folder. You didn't put them up there. Unless you happen to leave them in here. Although I don't really remember anybody leaving any pages every time. If they're not, hopefully you didn't have any really important notes in there. I'm going to take notes in your book. So this is the point where you practice right now. When I turn this over and I'm going to start walking around. So again, this is the point where I'm also grading you because I may not give you a physical grade for this, but if I, huh? You don't have them either?
No, I lose mine.
All right, this is the last time I give you copies of you cannot lose, just keep losing pages. Last semester we didn't even have enough books. This semester, like I said, some people aren't used to them. Page 5 to 58.
This
It's
is
the whole first.
right on.
Well, again.
Is that the type of?
Look at the theorem. Is it one of the 4 theorems on page 21? Look at the theorem. What do you know about that figure? What's true about the angles? Look at the theorems.
Are you looking for?
So the way for the light bulbs.
I'm reading it. Oh.
What's the first theorem say?
Okay, then it's gonna do.
Oh, no.
It's really simple.
If the opposite angles are, it's the same. We just learned parallelogram.
What's that opposite side?
I wish I still.
So think of it.
I know, right? How does it look different? I literally, oh, it's right. I know this was what we just did 2 minutes ago.
I cannot see you do that.
Yes, 2 minutes ago. I just drew in that and we remember because Chelsea right behind you said, I think she actually read the third theorem and then Chelsea read the second one, which is the one you need.
If you did interrupt it, then I wouldn't get you at it.
Interrupting now. You're
Of
fine.
course, because look at his shirt.
I'm rubber, you're glue. I'll be thank you. A real mature man. Oh, I got it.
Yeah, no.
Is anybody nobody's using the board, right? All right, I'm gonna do attendance. Because it's way more fun. Oh, I hate doing attendance when I'm recording. All right, I'm not gonna. I'll do it on this. Physical. Let me do attendance real fast because I actually forgot.
Oh.
Also. Is it a question I can answer without being over there?
No.
No.
I think I know that I've got the paper memorized.
Right.
Maybe what you're asking.
Really? You promise? You
No.
promise?
Come on, your attendance wait for like 25.
No, I can't do it. I've already forgotten to do the first period attendance.
Well,
Thanks.
Okay, well, that sounds like you promise.
It is, and I'm fixing the U problem right now.
Shaking my head.
Oh.
SMH.
Yeah, it's just. Wait.
Let's do it play on the door. And then only 7 for on the back.
That's crazy.
17 kids all I had. Oh,
That
no.
can't be.
That's
I don't know.
I go back.
that. What? Well, actually, no, I say that. I can't get over a call. Well, hey, and you just wanted me to come over there. Just think about that.
You know what? Actually, stay over there.
Yeah,
Yeah.
it's over there. We'll show you from a distance. It's okay. You
Can
can
you-
like, go point with like the.
Can you read from over there?
I do read better farther away.
Oh, really?
Although that depends on how, because like with glasses on, then it gets a little tricky to see farther away. But without the glasses, I do see better.
He has a.
Like, probably.
Nothing.
Everything here. Yeah, everybody's here. That's great.
That's important.
It's so fun to say.
Oh,
Yo,
yeah.
I'm sorry, I just lost it.
I almost just lost one.
Everybody's here.
I just.
Jordan.
Mr. Gill.
Yeah. Hanging in there. Hey, every day he wakes up is a good day.
That's.
Do you think you'll ever run
No,
away?
stay your distance. Stay your distance.
Are you gonna?
Like, he can't go like from my door to the end of the driveway and back.
It's so sad. Why are you laughing about it?
Because you said he's never gonna run away. Like, I don't put him on a leash or anything when we go outside. He can't. What's the-
Yeah, right.
It's my favorite.
Oh my God. Back to the area.
Touching my door.
That's something the same.
Hold on.
Yes, thank you. I've got to stabilize my feet.
They hold on to pins. Hey, you want to know the worst thing in the world for girls? Probably touch every day over and over again. Well, I'm storing it. Metal is the worst thing.
I
And
know.
hands are the worst thing.
Funnier.
Correct. Stop. Why not? What could you do to make it? Like, say, if I did this, then they'd be parallel.
But like those lines with those arrows.
Yeah, the lines and arrows were on the same sides, then.
Yeah.
Good. Good.
Mr. Gill, how old are you?
Why?
It's actually not that old. I've had older dogs, really, than him that were fine, like that physically were fine. He's got 2 He's 13 and a half. I mean, he's been like this since he's 7, since his first surgery. Yeah.
Oh.
Yeah, my dog was,
Oh.
my first, like, when I was a kid, like, my dog from 7 to 24, almost 17 years.
Trump was gone for a month and then came back.
Are you kidding about that?
I'm not even kidding you. She.
Your dog got
died
hit by
like
a-
years after that. Yeah, she had like a giant.
Some male drivers drive way too fast. That actually happened where my parents lived. Their male driver hit a kid and killed a dog and their man.
She came back alive like after like a month.
This one did not.
No clue what you want.
My dog got attacked 2 times.
She
Did you do anything?
I don't know that was. No.
Oh my God, are you serious?
Stop it. Stop.
That's another one.
That's way.
Saying too ugly, like I don't.
Either left it in here or we've been using it for 2 weeks.
You're laughing, but like, no, I got really mad.
What did you get for 3?
Yeah, 7.9.
You pointed out.
Why? What? Don't.
I just saw somebody that said no bueno. What about They got that is.
But yeah, when you saw it, that only 5 seconds.
I love playing times. Times are so fun. You know, 71.
What am I wrong?
You can look at 3 again. Look at 3 and look at 7.9.
Period. I think it's like.
You guys may wanna discuss that again. Yeah, both pairs.
Wait.
That's only one pair.
We don't need that.
Yeah.
So,
I didn't catch that.
what do we recommend? Right, so number 1 would be 7.9.
This one.
What do you guys get for one?
I got yes.
258. Where you go anywhere. Hang on to that.
I don't know.
What she's saying is.
Not yes.
I don't think I think that was I did. That was wrong.
Number
I
one.
don't think, yeah. That's like 27 points.
You need both pairs. That's only one pair.
So I said.
All right, so really quickly, we're gonna go over it. And say the answers. Some of you are just writing the number of the theorem, which is fine. I don't care, but just know now when you go back and study, you're gonna be looking back to see what that theorem was. So if you wrote the theorem out, it's probably gonna be better for studying, but that's up to you. Answer to number 1. Who am I gonna call on? Ava. What's the answer to number 1? What? Sleep in. That's how accidents happen, right here. You sleep, and all of a sudden you have a dream you want? Yeah. With what? Why? Why did you say? Which theorem? So 7.12, is that we all got for number 1? All right, so 7.12 was the new one, right? So if, yeah, that was what it said. So if you have opposite sides that are the same length, that are congruent, and those opposite sides are parallel, that's all you need. You don't need to know anything about the other pair of sides. So that's a parallelogram. What about number 2? So it's a yes, then apparently 7.9 says what?
It says if both pairs of opposite sides are gradual.
No, it's 7.10.
You told me 7.9. I did not. You said the first one.
Yeah, that was 7.9. I'm sorry, 7.7.
Nobody was in the
Right,
first
yeah.
one.
It's literally, that's the one that we had that conversation about. I said, what's the
That's the one
second
we're
theorem
talking
look
about.
like?
That's the one I was talking about.
I know, it's the second theorem. So it should be 7.10, not 7.9. So opposite angles are congruent, then it has to be a parallelogram. What about 3? Brian? I know, right?
He's kind of looking for the pages.
Oh, you guys are,
Yeah,
how is that the 4th person? This one makes me angry.
But I found mine, that's the difference. I found mine, they were just under here. I left them here. Enough space.
All right, well, look at it real quick. I'm making you answer it still.
Yeah, Brian.
Here, I'll help you out. I'll make it so you don't have to look back and forth. These are the 4 theorems. If one of those 4 applies, then it's a parallelogram. If none of them applies, then it's not a parallelogram. No, you gotta memorize them, yeah. Yeah, I mean, it's only one new one. This is the only new one. Those we already learned, well, you were supposed to learn them for yesterday. Yeah, number 3. So Brian is, you need to come up and, you don't borrow my glasses? Actually, these don't work. Those don't work. They don't work far away. They only work up close. I'll read them for you. How about this?
I think it's 7.9. That's the.
So are both pairs of opposite sides congruent? Both. Number 3. Number 3. Both pairs.
No, so, oh, yeah, both.
Both means the left and the right are congruent and the top and the bottom are congruent. So that one doesn't work. There's nothing at all about angles, right? So we can skip that one. Is there anything about diagonals? Nope, no diagonals. And do we know anything about parallel lines? Is there any markings saying anything parallel? No, that'd be the little angle thing, like the little, arrow thing. So, did any of those work? Then it's no. Number 3 is no. None of these 4 works. What about 4? Phones up. No. Yeah, let's go to this group over here. You got to do it together. So one person speaks for all. Number 4. All right, so 7.9, does that sound good?
Yes, yes.
So I believe that's opposite sides are congruent, right? Top and bottom congruent, and then left and right's congruent. All right. No, I heard you guys talking. Well, doesn't always mean Logan. Doesn't always mean Logan. Logan sometimes can be talking about other stuff.
Don't blame it all.
I'm just saying, like, it's true. I thought they were the social ones. You're the social one. I've learned. Savage. What are we on? 5.
Is it 7.11?
I don't know, is it?
Because it says if the diagonals of a quadrilateral bisect each other.
And did it tell you how congruence marks telling you they bisect?
Yes.
Remember, here's the tricky part of that, Bushy. There's multiple ways for me to tell you that 2 lines bisect each other. I don't have to just say these 2 lines bisect each other. The more common way is going to be what I'm guessing they did. Yeah, they just put congruence marks showing you that basically you have a midpoint for both lines. So just understand that's bisecting without them actually saying the 2 diagonals bisect. Oh, and then 6. Now, Zero, what do you think about 6? Here, I have them up there, so you can just look at the picture and you can go through these. Are the opposite side, opposite pairs, things top and bottom and left and right, so they congruent. Are both top and bottom and left and right? No, right? What about angles? Are opposite angles congruent? Look at the picture for 6. I don't know what it looks like, so. The opposite angles are congruent, both pairs of opposite angles.
What if the,
There's nothing at all about angles. Parallel, I mean parallel. Talking about the little arrow things on the line, that means parallel. So is there anything at all in 6 about angle? Nothing. It can't be the second one. Are there any diagonals in it? For 6. No diagonals. Is one pair of opposite sides, so either top and bottom or left and right. Are they parallel and congruent? One. No, right? Opposite sides are congruent, but then the other ones are the ones parallel. That doesn't work. So none of these work. So number 6 is a no. No bueno. All right, so there'll be one question like that on your big quiz. That won't be your exit ticket. All right, so here's the next piece. I'm gonna do this super fast. What do we know about parallelograms? Give me the first 2 easy ones. So the opposite sides are congruent, the opposite angles are congruent. Again, this is a big quiz question right here. If I give you some kind of an image, this is more of a 3D type image. I don't know that I'll do that, or if I'll just give you just a regular looking image, parallelogram, possibly parallelogram. Hold on, let me draw something in to help you visualize this. That, and then if I imagine. Oh, kind of messed it up. That's fine. I just felt like coloring. Or am I uncoloring? I'm not sure. Or am I erasing? But how do I erase something that's not like really technically erasable? Just drew over it white.
Yeah.
All right, so if I give you an image, and if I just say, prove to me that that is a parallelogram. Or they say it a different way, same concept. They say Find, again, this is example 2 in your book, so you can read it there too. Find the values of X and Y so that that is a parallelogram. Well, what would have to be true of a parallelogram? Oh, what is this about, first of all? The information they give us, what's it about? Arraya. Oh, guess I'm calling it. Arraya, what's it about? Look at the picture. What's the key that I say look for when you see different like little about angles, right? Look for the degree symbol when you get expressions. So I know this is about angles. So now the if. Now that I know it's about angles, if it's a parallelogram, which I want it to be, I want to kind of find the correct numbers so that it would be a parallelogram. What's true about the angles of a parallelogram? What is true if I had a parallelogram, or in order to, I'm really kind of thinking in order to make this a parallelogram, what has to be true about the angle? Well, that's about the size, the same concept. So what's true about the angle? Which angle? Opposite or across is fine. I actually like that better, to tell you the truth, even though they say opposite in the. So that. Yeah, I'm gonna change it. I was gonna leave it, but I'm gonna change it. I don't want that color anymore. That angle. In order to make this a parallelogram, I have to make those two angles equal. And I also have to make these two angles equal. So they want me to find the value of X and the value of Y that makes those two different things equal. So I want you to try to do that now. If you don't know what to do, I'll give you a hint in a second. The rest of you get instructed. I actually had a problem I was going to do for food today.
Can we do it?
Because I wanted to pre-stop what I tried means. Did you read it?
I can we do it?
It was up. Clearly, you didn't.
But I did. It's right.
Oh, did you do it?
Yeah.
All right, maybe I'll come around and look through for you.
But I didn't finish it.
Yeah, I wanted to talk more about this. I was just gonna move that to Thursday. Even though it's old, it's still appropriate for the retake. We just said Mr. Griffin.
Oh.
Oh, that's what we just said, Mr. Griffin. You know, I'm coming over to, you know, who I'm coming over to, no.
I started smiling right when you went.
Yeah, I started. I was like, yeah, she knows. That was funny. I totally saw that.
I did my work.
I'll give you like another minute, then we'll, if you're not sure about what you're supposed to be doing, now that most of you, I think, have probably started. If I want to make it a parallelogram, I just have to set the opposite angles equal to each other. Literally set those two little expressions equal, and then I solve for the variance. So we'll work it out in a minute. The big test, not here. Yeah. Oh my goodness, very good. We don't want any. We don't want any.
You don't want it. I'm weird.
What? Is that Owen still?
No.
Who's that? That's hello. Hello.
I forgot.
I know.
I don't know.
Those are me.
Mr. Engelhardt.
Oh, Miles, you want me to answer him. What's my first equation, Miles? Well, what's the equation? You solved it, but what would the equation be? 56 would have to. No, what's the equation? Equal sign means equation. 56 would have to. There you go. What? You did the math. Yeah, 7x, right? You need to get, some of you are pretty good at figuring stuff out, but when it gets tougher to figure out, you need to know how to set the equation up so you can solve. They have to be equal, right? That blue angle, again, follow that process. Circle what's in the angle, because that is the measure of the angle. that angle, 56, has to equal that angle, 7x. And then just 70. Right? I wouldn't do that with anybody. Not that I didn't think you did. But you did say, oh crap. So now to solve it out, this means 7 times x, so I need to do opposite math, which is division. So you should have gotten x is 8 for that. So for y, same exact concept. Trish, I know there gotta be something I haven't called out. What's my equation? Oh, girl, speed up. What else? 4y plus 4. So some of you are still struggling a little bit when we have variables on both sides of the equation. You cannot just add 4y and 5y. That's not 9y. So remember, the goal when we're solving is to get the variable by itself. I can't get a variable by itself if it's on both sides. So I have to think about getting rid of it on one side. That's how you get something by itself. You think about getting rid of it on one side if it's on both sides. So if I get rid of it over there, that forces me to get rid of it there. Now I have y subtract 26 equals 4. And again, if I want y by itself, I have to get rid of 26 by doing the opposite, adding, which means I'm forced to add 26 over here. So you should have gotten y equals 4. I'm holding miles, but I'll let you go now since you answered that one. I haven't even been writing anything on these lately. They haven't. As long as you don't.
She needs a calculator. With me. I feel whispering.
Hey, we know that Gabby's not gonna whisper it, so. Exactly. Has nothing to do with the fact that. All right, so that should be a pretty easy one. If something like that is on the big quiz, it will not be your exit ticket question. Exit ticket question is easy too, though.
I know what I'm saying.
We take it.
Well, no, I'm saying the one I give you for the exit ticket is easy. I would say it's easier than that. Again.
That's what you do for that one?
Yeah, you just, again, in order to make it a parallelogram, we just have to make the opposite angles.
Yeah.
And it could be the sides, so don't forget,
Huh?
I could give you information about the sides and it's the same concept. Both pairs of sides would have to be equal. You'd do the same exact thing.
Okay.
Except the side, and you would know it's about sides because there wouldn't be a degree
Top and
symbol, it would
bottom?
be out,
You would-
like, yeah, like top and bottom, left and right. Why did it? Where's my scroll bar? Weird. What?
Like a voice.
Nope. 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 Oh, that was weird. All right, so here's your exit. I'm gonna give you an image on called a coordinate plane at the graph.
What game is this?
Oh, here, let me zoom way in. Example 3, it should be right after the erasure. No, it's not before. Example 3 can't be before it. Here, I'm gonna zoom in even further. There we go. So I'm gonna give you a picture. Looks something like that. There's a check problem after this too that you can try to. And I'm gonna say, I'll probably say one of two things specifically. I won't even make it for the exit ticket. I won't even make it that difficult. I will either say, prove to me that the image below is a parallelogram, or prove to me that the image below is not a parallelogram. So now let's talk about the features. Well, there's really no solving because there's no many equations, right? So let's think about what is true if something is a parallelogram. Again, We're kind of doing a lot of review also for people doing retake.
Opposite.
So one thing we could prove, if we could prove that both pairs of opposite sides are congruent,
Yeah, but.
then we could say, yes, the only way that can happen is if it's a
That's
parallelogram.
7, 10.
Can we prove that opposite sides are congruent somehow? When we have an image on how, so good Lord. So we would have to somehow be able to figure out how long all those lines are. Is that possible? Is there even a way to do that? Have we ever done something about figuring out? Maybe something up on the board still?
Nuh-uh.
Bring that up.
Nuh-uh. Where?
So
I know, it makes sense.
the distance formula allows us to solve for the length of any line. I can take this point, which is -2, 1, 2, 3, 4. And then this point for G, which is what, 4, 2. And I can solve for the length of that line using that formula. I'd say right now it'll be way easier than that. Because what's true about two of the lines on here that makes it really easy to figure out how long they are? Yeah, I don't need to, if they're going straight up and down or straight left and right, I don't need a formula, I just count. 1, 2, 3, 4, 5. Oh, I didn't quite make a big enough jump. 5. That was 5. What about the one on the right? The same? Can it be a parallelogram if they're not the same?
No.
Not a parallelogram. Done. If they are straight along grid lines, look at the check problem. Can't count on the check problem. So I'm going to show you how you'll do the check problem using this problem. So here, I'm not going to do there's also a way, like if you read the top of the page that you're on, it tells you the 3 ways that you can do this. I'm never going to use the midpoint. I don't think there's ever a situation. I mean, maybe there is, but I can't think of one when I couldn't do it these other 2 ways, either by just finding the length of the lines. Or what also has to be true, this isn't actually a theorem, it's just kind of the definition of what a parallelogram is. What has to be true about the sides of the parallelogram? In addition to being the same length, what's like the most basic thing about it? In the name of the parallelogram. They have to be parallel, right?
Yeah.
The top and the bottom have to be parallel. The left and the right have to be parallel. What's true about, and we did this when we did parallel perpendicular, what's true about 3 parallel lines? What did we use? The math term we used when we did parallel and perpendicular.
No idea.
I'll give you another hint. This too is still up in the.
Oh, the thing that's on the wall. That's in the room.
Wait, talking about right angle? I mean, if they're right angles, yeah, but they won't always be right angles for parallelogram.
Wait, like up on the wall.
I didn't say wall, I said it's still up in the room from when we did.
It's up
Why?
Yes, what is that?
Rise up,
What is that? The formula for
why?
slope. If 2 lines are parallel, they have the same slope. So what we could do, and it's pretty easy with the ones that are, again, straight up and down or straight left and right. If they're both straight up and down, they have the same slope automatically. And I'm fine with just saying that. You don't have to go through the formula for those. Just say, well, yeah, those are both horizontal, so they have the same slope. Or those are both vertical. So that and that are vertical, they have to have the same. You don't need to do the math on that. So we just need to figure out the slope for these 2 lines, the 2 red lines, FG and JH. And then if it's the same, then we know those are also parallel and it's a parallelogram.
Yeah, check for both, right?
Yeah, because you need to know the slope of both. So I need to know the slope of FG and the slope of JH. How would we could plug it into that whole, and you get that top one on the quit or like on the reference sheet. That's on there. I wouldn't use it if you can remember the other one. What's the other one? The simple one.
Oh,
It's up on the sheet also. What's the other one?
oh,
I'm just pointing.
um,
Yeah, rise over run. If you have a graph, this one is way easier, in my opinion. Because I can just slope. We're figuring out the slope of these two lines. So the slope is simply the rise over the run. So I go from point F to point G. I always go right first, personally, because then I always know my run is positive. Because if I'm always going right, not right now. So how far do I go? I'm going from F to G. I can't go diagonally. You don't remember how we did slope. You can only go left and right and only go up and down. How far right did I go? So +6, because I went to the right. Now what do I do? To get to G, I have to go down 2. Down is negative. Don't remember that? We'll have to practice.
That's bad. You know.
You're bad if you don't. So that is my slope. -2, 6. Oh, shoot. Wrong one. What? Oh, wait. No, I put it in the wrongs. I mean, I guess I did that part there. That goes with FG. I put it wrong.
So they both.
So now JH, we do the same thing. How far? So again, I'm going to go from J to H. How far right do I need to go? Actually, you figure it out. You guys do this that part on your own. It's in your book. So you're doing example 3. Figure the slope of JH out. I forgot it was in your book. If I figured out the top one for you, you do the same exact process. Let me finish it up still, Daniel. Yeah, you got tons. So everybody finish it. Nobody yell it out yet. I know you're all dying to yell it out. I did the top one. You have the top ready. So if you'll recall, we made an agreement. Doing that. You better hope Miss Ludy's really nice. I'll kind of give you a few more seconds to wrap it up.
This for the.
Yeah, this is to determine, because if the left and right are parallel and the top and bottom are parallel, then it's got to be a parallelogram. That's kind of the definition.
So the FG has to match J.
And we know the left and right are parallel because they're both straight up and down. So if we get the same number again, then the top and bottom are parallel. And this is really not as easy as counting for this one, but when you do the check problem, this is kind of the only way, or not, it's not the only way, but it's certainly the easiest way to check problem. All right, so Isaiah, what'd you get?
yeah, what you got?
So again, 1, 2, 3, 4, 5, 6 to the right. Down 1 is negative. That same number? Can't be, right? I got a 1 on top of one and a 2 on top of the other. If you get numbers that are a little tougher to figure out, how could I compare those two numbers if they were a little, like I had a different number on the bottom? Like, was it a 6 on both? I think Chelsea might have said it. Would you say?
What do you think?
Well, we could simplify it and that would actually work in this one, but there might be some where we can't do anything else. No. There is a way to do it that way, but there's an easier one. I want to change them into something else. Easier to do. Not whole. You're on the right track of things. What's easier to compare than fractions? We can just look at them normally and tell if they're the which one's higher or lower.
Decimal.
Oh, yeah, that's something.
Perfect.
Nice.
Or just from vote the decimal.
We are. I'm guessing at this one, but I think this is right. That's not right. You can let me know. Is that the same number? One's 0.3 repeating, one's 0.16 with the 6 repeating? No, definitely not. Just make sure if you convert it to decimals, you understand it has to be the exact same. These two numbers are not the same. 0.3 repeating is not the same as 0.3. I mean, they got to be exactly the same. So you got to carry it out as many decimals as you need to see if they're the same number or not. That's your exit ticket right there. So I'm going to give you, so if you want to try the check problem on your own, you have to explain. Oh, so part of it will be showing me the math. Part of it will be then explaining how you use that math to make a conclusion.
What do you, what?
So we would have to.
Okay.
If you just, I mean, if it's like,
Can I go out there?
I'm fine if you have 2 6 and 1 6, I'm fine with just saying those are not the same. I mean, I hope you understand it's not the same. Because remember, they got to be the exact same. So if you just look at it, it's not the exact same, then you should be good. Oh, and then if you do it the other way where you can count, just say the left and the right side aren't the same length, so it can't be a parallelogram. Or the top and the bottom aren't the same
What
length,
the check is
so it can't be a
different.
parallelogram.
Yeah, really good.
So either slopes are not the same or they're not the same length. That's pretty much all you gotta say. But then you gotta show me how you know that.
A, B, and DC. Just go.
Yeah, so you have kind of have to do. You could do the distance formula and figure out the length of every single line, but that would be way longer than just doing the slope. In my opinion. You do have to do the slope 4 times. You got 4 lines. And the slope of all of them.
Yeah.
All right, so I'll let you work on the check problems since that's your bell work. Also, here are your next problems. If you didn't already write it, page 25, I also said number 9 and number 10. You didn't write that earlier. But page 26, number 11 is just like what we just did. So again, that's an example for your exit ticket. And then number 12 through 15 is the same concept. They just don't give you a picture. They don't give you the image. They just give you what are the 4 points of the image. You can draw that out if you want. There's a way to do it without drawing it out. I don't know. Again, you practice as much as you need to practice. If you can do the example, the check problem, and number 11, and then go back and practice those again before the exit ticket, I think you should be fine without doing 12 through 15. So I'll give you a minute or 2 to work on the check problem. Oh no, I did attendance. I have a notebook, by the way, that somebody left in here. There's no name on it. I don't know when. I have no idea what period it is. It looks like it was on this semester, so it's like when we started doing angles and polygons. Yep. I mean, we can check. I wasn't even planning on checking it.
Oh.
We can if we get enough people done. Yes. You and Isabella can compare, 'cause I'm sure she did it.
Go back to that.
Go back to what I said. I tried. 26, but I don't know.
Your board is on the end of there, by the way.
No. No.
It's the last line. So.
Back when I was working. But no.
That's
I mean.
So you need to do that for, oh, you did it in this one.
right of it. Just 2 5 those alone as you live.
Oh, I should.
Right of it.
It's 5 days, 5 days.
And then
It is quite.
it is. You are too close to the table right now. You are too close.
You close.
6 feet apart.
Yeah, I mean, you guys show, well, yeah, I'd like to do, we will work that out, just mainly trying to figure out how it's gonna be. I still, on an exit ticket, I'd give that, assuming you got it. Yeah, I'd still give that credit. On a quiz, I might not be able to, but if you did everything else correct, and that's, probably wouldn't give you a 100.
What'd you do? Which one's the preferred, like, the rise or run?
I mean, that's the easiest way to me. I don't care which way you do it, as long as
Like,
you
no,
show work.
like, which one would you rather, like, rice first or?
Oh, that's the only, I don't care which one you do first, yeah. I always, because if I follow just one process, I'm gonna get confused. So I always go right first, then up or down, depending on, which direction. And in order to always go right, I have to start at the point that's on the far left. But again, what I would do is say, come up with your own process and just do it that way every single time.
So that one would.
Drum roll,
So that right there,
please.
put them into-
How many people made softball? Oh, it's only, it's 2-day trial.
No, you only need
What?
one. So you get, break down
This? Oh, why? Holy muscle is that bad. And it won't go away.
I know.
The only way a muscle goes away. Now, what can help you is wrapping it. I
Right?
don't know if you have like, what an 8 bandage is. Your long distance.
Remember,
You know what an 8 bandage is? I have a million of them. I used to have to wrap my legs. If
yeah,
it's not a bad pull, sometimes wrapping it really tight is enough to keep it from slipping work. Right. Oh, yes, I do. Maybe. Yes.
Why would you call it? I don't know.
It has Velcro on it, you tie it, wrap it, it's pretty tight.
It feels different.
Yeah, sometimes when it's takes it off, like if you wrap it too tight, you'll know it. But better to wrap it too tight and then loosen it a little bit. Like start to not be able to feel it. But yeah, I mean, again, I don't know how bad the pull is. Well, it's not that bad, and I still wrap it and prevent it. I mean, even if I felt perfectly fine, I would wrap them and it prevents it from being able to tear away. So, yeah. So wrap it tight though.
yeah, that's.
I'll give you another minute and we'll compare how we do it. Tell Amy to tell us how to do it.
It's just like- The problem solving is the only real hard part of it. So I focus on more solving. Yeah, when we see like the numbers inside of it, all we do is like, when it asks for your
Hey, do you compare with what?
yeah,
Watch this, guys.
so for this. We'll write down.
How do you do it?
I think.
Good.
So then.
Where to where? Yeah, so you start, that's the reason. So, yeah, go where?
Okay. So then you can.
Well, no, first.
And then when you're done, so go ahead.
Go up straight away. Yeah, here.
Yeah, so did we do?
So you went right one. Now you did what?
What is it called? Like back 10 years ago, be a twin.
Yeah.
Again,
if you look at it, Parallels, you have slopes, it's what up and right. Down. So you should have two positive slopes and two negative slopes. You just remember that also, then you'll never make the same positive thing. So what do you think?
So. He's going. I
have like a really.
One side. And then 7 minus 5 is 2, so you have 2 back, and then write down your answer.
Well, I'll let you finish that. I'll finish that. So you did so.
Yeah, do
it. Going down, so it's negative. That's all we say. Finish it out, and see what AD is and what BC is. So again, going right one is the run, that's the bottom one. Up. It goes right two. Oh, yeah, this is a different problem. No, because if I need to go to B, right? B is over here. 1, 2.
That's all you do, because I was
Be careful.
I mean, that's all I'm asking for.
Yeah, it's a lot lower.
No, I said it's not.
And
So.
Can I use the restroom now?
Like, I think.
yeah, I'm back.
But,
Oh, you're back.
yeah.
I don't know, but you've seen a big number.
Oh, you were? I'm sorry. Did you get this one? Like, are you good? Did you get your? All right, really quickly, I don't know if I may not have the check problem on here. I don't think I do. So I don't have the check problem up here, so we're just gonna walk through it.
Do you know which ones?
Yeah, the bottom number is, I always go right. So I always start from the left point and go right, or from the left point and go right. For that one, you run from what I remember was 2, and then you went up how many? 3.
Don't say that to myself.
So then you need to do that for the other line that's on the opposite side and see if you do the same thing. Do you go right 2 and then up for each side? All right, so I don't have that problem up here, so we're just gonna walk through it. So all right, we're just going over that check problem. So for that problem, I don't know what the letters are. What's the top line? What's the slope you got for the top line? You should have gotten -1/5. For the bottom line, you get the same thing. Yeah, -1/5 again. So those two are the same. Now we have to do the left and right also. Don't forget. It's got to be top and bottom have the same slope and left and right. So what'd you get for the left line? 2/3. What'd you get for the right line? And then 2/3 is somebody, is that right? Got that? So I was gonna say,
Oh.
I don't have a picture. Well, let me see if I can, I'll just create one. If you have an image on a graph, some of you are messing up with the negative sign part. Like you're not making it negative when it should be, or you're making it negative when it shouldn't be. If you just understand slope, we did slope before. If a line goes up, and I'll show you we did it. I'm showing you my amazing artistic talents. I said if I'm walking up a line, if I'm walking up a line when I go from left to right, it is a positive slope. I was like, I didn't even see what that. I'm like, oh yeah, to let you. So if I am walking down a line, which I don't really have one, because if I was over here, I'd still be walking up, right? I'm walking up, I'm walking up. If I had a, let's just draw one, I guess. If I'm walking down the line, colors, then it is a negative slope. We did that before. If you just remember that, so it's going to come back up again. It'll come up in some other lessons we do. If you remember that, you'll never mess up. Like as far as putting the negative there when it shouldn't be, or sometimes people put 2 negatives in it, which is correct, but then they think it's a negative slope, but it's not. It's positive. 2 negatives, one on top, one on bottom would actually make it positive. If I just know, oh, well, that's going to be a positive slope. Now all I need is the numbers. If I know, oh, that's going to be negative. Now I just need the numbers. I don't need to worry about what's what. Just count. All right. So that's your exit ticket. I think, again, if you really need more practice, you have number 11 on page 26 that you can do. These are positive though, because they're going up, left, and right. They should both be positive. So you got one of them negative, one of them. But I think you reverse them. You see, so you go over 2, so that's positive and up there. That one right. D, again, I go from the left point. 1, 2, 1, 2, 3. Same thing. So yeah, be careful. Just keep practicing that process. You're going to want to make sure you go and try to do 11. You might even want to try to do 11 on notebook paper, so you can then try it again, maybe like Thursday before the actual exit day. All right, let's see what else we need to do. Anything? We did all that. All right, so we're gonna start just really quickly, the quick thing on rectangles. So turn to the lesson on rectangles, page 31. Well, I'm actually not even doing an example. I don't think anything we do is fun. Except for proof. Proof is the one thing I say is different. Proofs is difficult. So far, again, some of the algebra, if you're good at algebra, then there's not a lot that's hard. The algebra is the tough part. You're not bad at algebra. I taught you in part of algebra. All right, so for a rectangle, we're only learning one new thing. So again, we haven't, it's not like we're doing a whole brand new lesson and getting all this new stuff. You guys have been pretty good, but that time to get you in trouble. We know for a rectangle what's true. You know rectangles, they didn't know rectangle, it's true. Say it again. It is. So what do we know about it? Like before we even knew that though, before we even talked about parallelograms, what do you know about a rectangle? Yeah, hopefully you know the top and the bottom are the same length, the left and the right are the same length. Well, that's just what parallelogram is. What about angle? What's true about the angles of a rectangle? Yeah, they're all 90, so everything's the same. So opposite angles are congruent. Well, that's parallelogram. What else do you know about a rectangle?
But those sides add up to 180.
Yeah, consecutive adds up to 180. Again, just like parallelogram, because it is a parallelogram. What else do we know? If we drew in diagonals, what do you think would be true?
That the bisecting, like that would be the opposite would be.
Yeah, they would bisect each other. If we drew in diagonals for a rectangle, they would bisect each other. So there's really only one new thing we're learning. Yeah. We're on rectangles now.
This is the only place.
Yeah, this one, I mean, it specifically says diagonals of a rectangle.
I thought
This will be on the big test.
the test. we take
Yeah, we're
today-
moving into the next lesson. We moved into the rectangles, which is still a parallelogram, and we're still doing parallelograms.
It's just
This
a
is
different
just a
shape.
specific type of
It's a
parallelogram.
different.
Kind of like a square is a specific type of rectangle. Oh, wait. Oh, you're so borderline. Oh, no, actually, mine's fast.
Oh, get out. 40, 46.
Oh, there's a teeny tiny picture. I know, so mean, right? So. Any of you get like jealous of your really good friends'
That's weird.
relationship partners?
No.
No, I mean, like, wait, what do you mean weird?
Why would you be jealous of that? They do. Yeah, weird.
Because they're spending more time with them than with you. That's why you're jealous. I'm discussing another student issue that. Yeah, you do get it.
If like your best friend is dating someone and they like blow you.
And all of a sudden they stop hanging out with you and they start hanging out with their friends. That's what I'm talking about. Not jealous because you want to be with the other person. It's not that. So just all of a sudden, like a lot of people, once they get in a relationship, they feel they stop doing anything. Yeah, but some people, when they get in a relationship, that's the way they are. They just spend all of their time with that person. Well, they do. Hey,
That's perfect.
Isabella, it sounds like we need to talk through some stuff at some point. If you need to come in, we can talk that out. We can talk that out. I think there's more to it than just what we're talking about for you. All right, if you say so. So here's the new thing. The only thing you have, oh boy,
How many questions?
why do I not have the bottom part? If I have a rectangle, that was really loud. If I have a rectangle and I draw in the diagonal, we already know what is true because it's parallelogram.
Yeah, because the, oh, man.
Well, what's true if it's parallelogram and we draw in diagonals? What's true?
All right.
Well, no, that's something else. We know they bisect each other. If-
Yeah. Something like that.
The next part is what we're adding to it. So not only is that true for a rectangle, which is true for every parallelogram, there's a new thing true just for rectangles. That's this.
Okay.
So not only do they bisect each other, but the diagonals themselves are the same length. What are my letters? AC congruent to BD. So here's what I could do.
Wait.
I could give you some kind of a figure that looks kind of like a rectangle. And I could tell you some numbers. And I could say, prove to me whether that, well, I could say, is that a rectangle? Yes or no? Prove, I'll explain, prove to me why. So what would you need to do? Depending on how much information I give you, there's two pieces to prove it's a rectangle.
What?
We're gonna go over it.
There's four sides.
When you say four sides, we're talking about the diagonals, because we gotta be talking about the diagonals for a rectangle. The only way, so again, refocus, I'm telling you right now, here's my understanding question, I'll bet you. If I have if I have an image that might be a rectangle, there is one and only, so it's definitely a parallelogram. The only question is it just a parallelogram or is it a rectangle? And I'm not gonna give you anything about the measure of the angles, so you can't say anything about 90 degrees. What is the only way to prove it if I give you something about the diagonals? What's cool? Not angles.
Side.
I'd actually have to prove
But they-
two types of congruence things. Like I'd probably put numbers in there or something like that. It's probably what it's
Sides.
Well, not about the sides, because again, the only thing about sides is opposite sides are the same or congruent. That's true for all parallel. There is one thing that is specific to rectangles, and that's what your focus has to be. I have to prove this thing, and if I can't prove it, then it's not a rectangle, it's just a parallel. Not about angles.
That's one.
What is the one thing about rectangles that we just learned? It's literally making fun of all.
Right?
No, no,
There's four, right?
there's nothing about angles. That is true.
It's supplementary. That's what-
No,
It was on the
I mean,
screen,
I literally have it underlined in blue on the screen. Yes, that's the only thing that is true for a rectangle. Everything is true for every parallelogram up above that. But if it's a rectangle, then this is true, and it's only true when it's a rectangle. So here's what you would have to prove. Depending on how much information I give you, you might have to prove that's true, first of all. Because that would prove it's a parallelogram, right? Because if it's a parallelogram, then the two diagonals bisect each other. Then what you would have to prove is this, that the two diagonals are also congruent, also the same. So I might give you something like this. Couldn't do that. How would I do it? I don't know how I put the numbers in there.
Good.
But-
Lost.
So let me ask you this. Oh, actually, here's a really good one. I almost don't even want to give you this one and just put it on the quiz.
Give it.
I might wait. I'm
No,
gonna
give
save
it
this
to
one.
us.
I think this is what I did on the quiz. Now I'm starting to remember what's in the quiz.
Okay.
There's something else you
Make
know.
us get it all.
There's something else you know also. Boy, oh boy. How can I at least give you a hint? I didn't do this. I'm not gonna do it because I didn't give it a second period. There's something else you know about if it's a rectangle. If it's a rectangle, there's something else true about those segments. I thought, I've already said 12.
You've already said. You're speaking.
We'll figure out who's getting who's
You are
not.
not alone.
You're not a leper.
There's something else you know about those little line segments in the diagonals. If it's a rectangle.
Like a little-
And if it's not a rectangle, then this wouldn't be true, this other thing.
Or they like give us.
Man, oh man, that is a good one. I'm glad again, I think I've already put this on the quiz anyway, but. Now though, it's all coming together. All right, so you have a bunch of problems you can work on to practice. We have one main problem, it's the exit ticket on Thursday.
Already did it.
We'll finish. There's also some other ones that are like the exit ticket too, though.
They feel pretty.
Oh, Mediterranean.
What do you mean?
That was only.
What page are the practices that we have to?
Oh, well, I gave it to you earlier.
I'm not-
Yeah, it should be,
No, you're not.
Right? That's how it is.
You can take a picture of it.
I did all the-